Hi everyone, it is Mrs. Voss. It is March 16th, Monday. Today's focus is going to be our lesson on AA similarity. AA stands for angle. So last week we talked about what makes figures dilated and what makes them similar. To prove similarity, corresponding angles have to be congruent and corresponding sides have to be proportional. And it was kind of a tedious process, but if you recall in Math 1, when you guys had to prove triangles that were congruent, you had to sometimes use angle side or side congruency statements, and now we can start doing that. So today's focus, like I said, is going to be on AA similarity property. And again, the AA stands for angle. Here is a warm-up problem to kind of remind you of what we did last week. So last week, we again talked about similarity and we were setting up proportions. So here, Sammy has a scale model of a World War II airplane, and 75/100ths of an inch represents 9.2 feet. And the model airplane that Sammy wants to build resembles an actual World War II airplane that is 220.8 feet long. The question is, how many inches in length will the model airplane need to be? So if you kind of look at the proportion I set up, I did 75/100ths of an inch over 9.2 feet. So my proportion setup is inches over feet. You could have done feet over inches. You could have done scale to the real airplane. So again, there are a lot of different ways you can kind of set up these proportions as long as you are consistent. So if I'm doing inches over feet, then I am setting it equal to, I do not know how many inches the model airplane needs to be, so I call that X, but I put it over the actual length of the World War II plane, which is 220.8 feet. And then if you notice, I am just going to cross multiply. In all honesty, by multiplying the 75/100ths with the 220.8 feet, I am able to isolate my X. So this is equal to X, and then I'm going to take this product divided by the 9.2, and I get my answer of 18 inches. So the model needs to be 18 inches. Now, this particular warm-up is in your workbook. It's on page 53. Something I should have mentioned earlier, but all of these lessons will be posted in our Google Drive folder. And, if you want to just kind of observe and listen instead of writing things down, I totally respect that. Especially something like the last example that's not in your workbook. But now maybe you could jot down some notes. We are on page 53. So we are talking about the Statue of Liberty. Okay, it was given to us from France in 1886, and it stands at 93 meters tall. A replica of the famous statue is 7 75/100ths of a meter. What is the scale factor comparing the height of the replica to the actual height? So if you remember, we talked about scale factor last week. Scale factor is our K value, and we thought of it as the prime over unprime. Or basically the prime is our new size of the figure, whether that's an enlargement or a reduction, over the old, which is really the original. So basically, in context of the problem, we want to kind of find the scale factor by setting up the replica over the original. So here's my setup, here's my scale factor. Notice the units cancel. When we talk about the K value, the scale factor, there are no units. Moving along, if the height of the base of the actual Statue of Liberty is 46.5 meters, what is the height of the replica? So notice I'm doing replica over original. That's how I got my K value, my scale factor, and I'm actually going to use that in my proportion. So X is going to be the height of the base of the replica over the original. And again, I'm just going to really multiply this way and then divide by 12, okay, and I get my answer. The way I wrote it here, you could really kind of think of it as multiplying by the reciprocal. So taking 1 over 46.5, and if I flip it over or write it as the reciprocal, which is 46.5 over 1. And what I do to one side, I better do to the other side. And this is how I get this set up. And again, confirming my answer. This slide is just the same thing that I walked you guys through. It's just nicely typed up. Sometimes I have a chance to do that. The objective. Proving triangles are similar by a similarity statement and finding missing side lengths and angles for similar triangles by using this property. So basically the algebra that's involved. Okay, just a little bit of notes. Like I said, page 54 seems to be blank if you want to jot down some notes. Angle-angle similarity statement. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar by a similarity. Okay. And I'll kind of explain why we don't actually have to show all three are congruent. Okay. So first of all, look at the triangles I just kind of made up. Okay. Based on the markings, I can conclude angle A is congruent to angle M. So I'm just going to write in 20 degrees. Based on the markings, angle N is congruent to angle C. Okay, so we've talked about this before. The sum of the interior angles of all triangles have to add up to 180. So that means if angle A is 20 degrees and angle C is 110, which is 130 degrees, that means angle B has to be 50 degrees. So the measure of angle B is equal to 50 degrees. But I mean, if you think about it, if angle N is 110 and angle M is 20 degrees, that too adds up to 130, and therefore angle L is congruent to angle B. So this is how a similarity property works. If you can get 2 out of the 3 angles in any triangle to be congruent, you don't really need to prove the third one. It's kind of additional work. It's unnecessary. So let me mark. So by a similarity, I know that angles B and L are also going to be congruent. Well, so really using the fact that the sum of the interior angles of any triangle adds up to 180, I know that angle B and L are congruent, and then I can basically state that triangle ACB is going to be similar to triangle MLN by a similarity, just to clarify. So what are some other similarity statements? So the order of the letters matter. So for instance, I call this triangle ABC. It's similar to triangle MLN by a similarity. Okay. But if I want to call it triangle CBA, then I would say it's similar to triangle NLM. So the order of the letters do in fact matter. And here are some other similarity statements. Hopefully you were able to come up with these as well. All right, so remember, triangles are similar if their corresponding angles are congruent and their corresponding sides are proportional. This takes us to example 1 on page 55. Explain why the triangles are similar. Write a similarity statement. A similarity statement I will show you, of course, but that's just saying that the which triangle is similar to which triangle. So look at my little star, look at my little side note. So if you recall from Math 1, angles 1 and 2 are going to be congruent. Let's mark it. Because those are considered vertical angles, and all vertical angles are congruent to each other. All right, so now what's given to you is angle A is congruent to angle D, angle B is congruent to angle E. Okay, so my conclusion is the triangles are similar to each other by a similarity. And then these are considered the similarity statements. Okay, all of these are true. Like I wrote in my side note, I only need one of them. So if you just gave me this one, that is totally fine. If someone else gave me that one, great. Okay, I just need one similarity statement. Okay, here's another example I just kind of put together. Why or why not are these triangles similar? So if you recall, these arrows, okay, mean that sides AB and DE are parallel to each other. So I'm bringing back parallel lines and transversals like you did in Math 1. Okay. So if I was to kind of extend this, here is my transversal. And if you guys recall, you would hopefully tell me angle A and angle E are congruent to each other, okay, by alternate interior angles. You know what? Someone else might tell me that angle B and D are congruent by alternate interior angles. That too is also fine, okay? And honestly, that would be enough to prove that triangle ABC is similar to triangle EDC, because now you have two different sets of congruent angles. So by AA similarity, the triangles are congruent. Maybe someone else would say angle A and E are congruent by alternate interior. And then maybe someone would say angle BCA and angle DCE are congruent because these are vertical angles. Okay, I'm going to call it angle 1 and angle 2. So angle 1 is congruent to angle 2 by vertical angles. Okay, thus triangle ABC is similar to triangle EDC by AA similarity. So in all honesty, there's probably 2-3 different ways you could prove these triangles are similar. All right, this takes us to page 56, example 2. Explain why triangle ABC is similar to triangle DEF, and then find the length of triangle DF. So what I'm kind of like marking over here is, notice that the order of the letters matter. So first of all, the triangles are similar because, as I highlighted, They told us A is congruent to D, C is congruent to F. So by AA similarity, the triangles are congruent. Okay. Again, a similarity statement would be one example. Triangle BAC is similar to triangle EDF by AA similarity. Okay, so because I know this and they want me to find segment DF, look at what I marked. DF needs to correspond with AC. So look at how I set up my proportion. I want to find DF and I'm putting it over segment AC, 6.9. And that's equal to, so I'm going from like the little triangle, okay, over the big. That's how I'm setting up my proportion. So I'm going to go back to the little triangle, find another side, 2.72, and I'm going to compare it with the larger triangle's corresponding side. So here's my proportion. I'm going to cross multiply. So I'm going to multiply this together with the following, and then I'm going to divide by 3.4. And here's my segment length for DF, 5 and 52 hundredths of whatever unit we're using. Over here, I just wanted to show you, there's a different way you could have set up your proportion, but you will get the same answer as long as you're consistent. So I chose to stick with the same triangle. So I did segment DF over one of its other sides, 2.72 is equal to, now I went to the larger triangle and the side that corresponds with DF, 6.9, and put it over the same triangle, another side that corresponds with the smaller triangles, 2.72. So here's just another way you could set up the proportion and still get the same answer. Like I've been kind of saying last week, there's more than one way to set up these proportions and still get the same answer. Okay, this takes us to example 4. Honestly, not that bad of a problem, but they try to trick you because they change the units on you. So here we're using feet and inches, and here it's just feet. So we just have to do a little bit of converting. Suppose a person is 5 feet 10 inches and they cast a shadow of 3 feet and 6 inches. So let me underline that. That is a person's shadow. So we're comparing like height and shadow. Okay, at the same time, we have a flagpole whose shadow is 12 feet long, and to the nearest foot, how tall is the flagpole? Okay, so we want to find the actual height. All right, so if you notice, I thought it just might be a little easier to change everything to inches, and then once I have a final answer in inches, I can convert that back to feet. Not necessarily the only way you can do this problem, but I thought this might be the simplest. Okay, so 5 feet, right? The person is 5 feet. So I did 5 feet times 12 gives me 60 inches. But that person was 5 feet 10 inches, so I'm going to add that in. So for the person, okay, the person is 70 inches. Okay, the person's shadow is 3 feet 6 inches. So similarly, I did 3 times 12 plus the 6 additional inches. So the shadow of the person is 42 inches. Okay? All right, and then this is for the flagpole. So I'm going to say person's shadow. Okay, and this is the flagpole's shadow. I get 144 inches for that. All right, here's how I set up the proportion. So I did person over the shadow is equal to the flagpole's height over its shadow, all in inches. So basically when I solve for x, I cross multiplied. Here's my setup. X is 240 inches. Okay, this is in inches, but by dividing it by 12, it puts it back into feet because the problem wanted the answer in feet. So there's my answer. Okay. Here's another way people might have done it. Some people might have wanted to change everything to feet. So 3 feet and 6 inches is really 3.5 feet. I changed it to an improper fraction. 5 feet and 10 inches is really 5 and 5/6. Okay, so I changed this to an improper fraction. So this is all in feet. Okay. And then as you can see, I just divided, okay, and 1/12 with the units. Okay, and if you notice, okay, so I have here, I am basically dividing the person's height. Okay, over the person's shadow, and it is equal to the flagpole's height, which we don't know, hence I'm calling it X, over the flagpole's shadow, which was already conveniently given to us in feet. It is 12 feet. And ta-da, I get the same answer as my other setup where I wanted to convert everything to inches first. All right, this should be our last example. Thanks for going through all of this. So let's finish it up. Example 3. Okay, identify the similar triangles, find X and the measures of the indicated sides. Okay, so the markings are really important. Okay, so you definitely want to pay attention to these markings. You know me, I always like to kind of highlight. So segment AB, okay, should correspond with HG. So I definitely want to use HG and AB because I want to solve for X. So I'm kind of going from big triangle to little. X plus 1 over 3 is equal to, so I go back to the big triangle. Oh, they gave me side AC, which we're calling X plus 5. And AC corresponds with the smaller triangle side length of 6. So here you go. Here's my proportion. Once again, cross multiply. Okay, I am being purposeful. I am using parentheses over here. 6 times X plus 1 to remind you guys, please distribute that 6. That's how I get the following. Likewise here. And then just some basic algebra. Solve for X, and X is 3. Okay? Here's, again, just another way to set up the proportion. Do I care which method you use? No, because it gives us the same answer. All right, and then lastly, it said find the measures of the indicated sides. So I just had to go back and substitute. So if my X value is 3, X plus 1, that's how I get 4. 3 plus 5, that's how I get 8. And then just a little side note, notice 3 over 6 happens to equal 4 over 8, and that is all 1/2. Okay. So just a good way to check your work. Okay. Problem-based task, it is a good problem. I try to highlight. Basically, they want us to prove whether or not triangle ABC and triangle ADE are going to be similar. So if you notice, triangle ADE, and try to highlight that in blue for you guys, and triangle ABC, I try to highlight that big triangle in yellow. They have angle A. So by reflexive property, that angle is congruent. They both have it. And then notice, if you read the problem, the vertical pieces of this truss form 90-degree angles. And you guys know that all 90-degree angles are congruent to each other. So therefore, angle AED and angle ACB, these are right angles. So therefore, angle E and C are going to be congruent to each other. All right, so by AA similarity, I got two similar triangles. Okay. All right, well, you know what? If I got two similar triangles, I can solve side lengths, because if the triangles are similar, the corresponding sides are proportional. Okay. All right, so first of all, I am comparing big triangle to the little triangle. So where the heck did I get this 14? Add up these side lengths. 5.25 plus 4.75 plus 4 equals 4 feet. So my side AC corresponds with AE, hence this setup, this ratio. And it's equal to, so again, I did big triangle over little. So let's go to the big triangle. Oh, okay, this vertical height is 4.5. I don't know what segment DE is. So that's my X, and here you go. If you do the math correctly, you should get approximately 1 7/10 of a foot. And then you could just kind of see my little side note. So I've given you multiple proportional setups. I am consistent every time, but notice I'm always multiplying the same thing together, and therefore I'm going to always get the same solution. So, of course, if we were in class, having normal classes and everything, this is what your homework would be, page 59 through 62, 1 through 10. I think it's very doable. To be honest, just to give you a quick overview, if you glance at your homework calendar, in all honesty, we really just had to kind of get through 3 lessons. So we just got through one of them. It is under 30 minutes. So thank you for kind of following along. Go ahead, work on this assignment, and hopefully I will see you guys in a few weeks, and I'll be happy to give you guys some credit then. So it really doesn't matter if you're listening to this lesson today on Monday when I'm recording, or if you listen to it next week. But just want to give you a heads up, and I'll try to paraphrase all this in an email that I send out to you guys. But really for Unit 5A, we just had to kind of cover 3 different topics. And I think I'm going to kind of stick with that plan for what we need to do this week and next week. Okay? So thank you again for your attention. I do hope you all are being safe. And I do hope we will get to see each other soon in April and have some normalcy. But do take care of each other and yourselves.